Let us see polar curves here. Here I have a problem of a cardioid. So let us see that. So let us trace the curve for R is equal to A into 1 plus cos theta, right? Here A is greater than 0 and theta, which lies between 0 less than or equal to 2 pi. Okay. Yeah. Yeah. So this is the curve, which is known as cardioid. Okay. Okay. Now let us look at this. How do we trace the curve? Okay. When theta is changed to minus theta, the equation remains unchanged. That is, if I put r is equal to a into 1 plus cos minus theta, so we get r as a into 1 plus cos theta. That's what I said. Okay. So the curve, uh, therefore, we can say that the curve is symmetrical, is symmetrical. Okay. About the initial line. Okay. Now, let us see the other case. Now, uh, mod of cos theta is less than or equal to 1. We have r is less than or equal to 2a. So hence the entire curve lies within the circle centered at the pole origin with 2a as the radius. Okay, so the radius is 2a. Now the next is r will be 0 when theta is pi. So you can substitute it. So 1 plus cos pi. So cos pi is minus 1. So this will be 0. Okay. So we can say that the curve passes through the pole and the tangent. Through the pole and the tangent. Okay. Now r will be 0. Okay. So when theta is pi, yeah, which we have seen earlier. Now, now let us differentiate this with respect to theta. Okay, differentiate with respect to theta. So it is dr by d theta, which is minus a sine theta, and tan phi is r. We know that tan phi is equal to r d theta by dr, right? So tan phi will be a multiplied 1 plus cos theta divided by minus sine theta. Okay, substituting r here. Okay, and substituting d theta by dr, right? So we get this as minus cot theta by 2, which is equal to tan pi by 2 plus theta by 2. So phi will be pi by 2 plus theta by 2. Okay. Now, when theta at theta is equal to 0, phi will be pi by 2. Okay. Now, now at the point that is when you substitute theta as 0, uh, you get r value as 2a, right? Yeah. So the tangent is perpendicular to the radius vector. Okay. Now r is a when theta is pi by 2. You can have a look at this. This is a into 1 plus cos pi by 2. So, which is a. Okay. So, you can say that the curve cuts at the line uh, when theta is pi by 2. Okay. So, it is a comma pi by 2. Okay. So, you have noticed that uh, theta increases. As theta increases, r decreases. Okay, let us see that. Let us see the corresponding table of theta and r. So as theta increases from 0 to pi by 2, the value of r decreases. When it is 0, we have seen that it is 2a, and pi by 2 it is a, and this is a by 2. This is 0, and a again 2a. Okay. And let us see by using Python. Uh, I want to show you the graph of this. Okay. So as I was saying here, uh, here the first thing we have noticed here that uh, it is a symmetrical curve because it as theta has changed to minus theta, it has not changed. It is remained unaltered. Okay, and we have seen that the values with respect to the curve from 0 to 2 pi, it is 2a to 2a. Okay, and this is uh, the mirror reflection corresponding to that will be r is equal to a into 1 minus cos theta. Okay, I hope you enjoyed the session. Thank you.